This is going to be the answer to question 3 for the 321 midterm. So we're supposed to explain the concept of widebanding using a Bodie plot. So imagine if we were, doing something with a signal and we wanted a constant gain and we wanted a bandwidth of, 0 to 10 to the 6th hertz. So this entire bandwidth, if we were using the bandwidth from 0 to 10 to the 6th, we could reliably, we would know that between those frequencies we would not experience attenuation. But if we were doing an application where we needed more bandwidth, say we wanted 10 to the 8th, we wanted 0 hertz or 1 hertz all the way to 10 to the 8th, we couldn't reliably use that because at really high frequencies we'd experience attenuation, and we don't want that. We want the signal to experience the same amount of gain for our entire bandwidth for our application. So what we can do is we can decrease gain. So if we add some impedance or some resistance or impedance into the feedback loop of the op amp, we can decrease our gain of the circuit to 40 dB, or just a different number basically. And if we decide to choose 40 dB, now that bandwidth is opened up to us from 10 to the 8th. So that new application whatever we're trying to do, if we need 1 hertz all the way to 10 to the 8th hertz, we know that our signal is not going to experience attenuation for that bandwidth. So it's a trade-off. If gain is the priority and we only need frequencies of 1000, we can go over, or we can go all the way up to 10 to the 6th. But the more bandwidth we require, we have to sacrifice gain. If for whatever reason we had an application where we needed 10 to the 9th hertz, the most gain we could be able to use would be 20. So it's just a constant trade-off. So again, if we're using 10 to the 6th, we're okay with a gain of 80 dB. But if we say, oh, we need to use 10 to the 8th, our bandwidth needs to be 10 to the 8th, you can see that we're going to experience attenuation of those high frequencies. So we have to sacrifice some gain for a greater bandwidth. But we can achieve all gain values for this 10 to the 8th frequency. I know that was not super clear, but I hope that got the point across.